In the following, I would like to give a brief introduction of Avato's dynamic data crawler outbound interface that can be used to extract data from an SAP system and which has many advantages compared to hard-coded ABAP reports. This tool was mainly developed to support a structured data extraction for our customer Zilliant. Zilliant offers their customers an AI-based price optimization, which considers a plenitude of data in order to determine, for instance, the best sales price. In order to do so, they require lots of data from an SAP system like customer main data, sales orders, price conditions, and so on. In the past, they developed individual interfaces for each of their customers to obtain this data. Due to different SAP systems, for instance R3 or S4, retail or non-retail systems, or individual customer-dependent environments with many Z tables, it did not seem to be possible to develop a standard interface. Nevertheless, development of a new interface each time a new Zilliant customer was supposed to be connected also led into many problems like delayed going live periods with many teasing problems. This is where the Avato Systems DDC DOI solution comes into play. It allows data extraction based merely on configuration, which is so flexible that the same configuration and the same extraction model can be used for different environments and even caters for all kinds of customer individual configuration and Z tables. In this short presentation, I will not be able to give an overview of all the features within DDC DOI. I will just go through a basic configuration, but that will be enough to create an understanding of the tool. I will now jump right away into an SAP system and show you some details of an already configured extraction. This is our configuration manager that is used to configure the extraction. And you can see that in our test system here, there are many extractions configured already, also some for our customer Zilliant. And by double-clicking one of those rows, we will be able to switch on the filter mode here and will only get display the configuration which is dependent on this selected extraction model. In the header table configuration, we can do some top level configuration like the root table to be extracted, the package size, which extraction type we use. For instance, we can have a free selection based on selection parameters, but also can have a delta selection and some other stuff. The next table we use to do the table joining, we call it PCC parent-child connection, but basically this is how to configure the SQL joins. And in this extraction model, we have basically sales orders and pick up the sales order positions and some partner information, some price information. And there is one little thing I would like to draw your attention to, which is a variant ID, which is one of the features which make our extraction models very dynamic. As you can see here, we use a variant ID R3 and S4, which means in an R3 system, this extraction block is used, while in an S4 system, this extraction block is used. And if there is no variant ID, then it will be used in either of the systems. The variant ID is a dynamically can be dynamically configured, so anything that can be connected to any data within the system can become a variant ID and can be used to make the extraction models more dynamic. After we did the table joining, we can do the mapping from the source data into the destination structure. And this mapping is not just a one-to-one mapping from source field to destination field. We can also have a move corresponding mapping. And we can also modify the data while it goes from the source field to the destination field. Modifying data is possible via the data manipulation variant. And for instance, you can see here some examples here. If you put more than one source field into a destination field, you have to tell the system how to connect this data. And here we do a paste trailing comma separated. Or for instance, here we put the date and the time into a timestamp field, and we like this to be an ISO timestamp. So we add the date and the time via the data manipulation variant. We also can connect conditions. So the source field is not always to be moved into the destination field, but only if the condition is true. Also here within the mapping, we have our variant ID column, which enables us to map information only in certain situations. In our example here, we map this stuff here in an R3 system, but take this stuff in an S4 system. Here there is some more configuration to be done. For instance, we can configure constant values which are used within the selection and the extraction. Also, the constant values can always be dependent on the variant ID, so we can have different constants in an S4 or R3 system, or dependent on any other situation. Like we can configure that we have a certain constant selection value for customer A, but have a different one for customer B, and so on. We can set up our selection fields for the extraction. In this example here, we only use the add date and the sales order number. We can set up conditions to make it even more dynamic, and some other stuff here. We can, I will go back into the mapping table. We can put all the source fields into a destination structure, which is based on SAP data dictionary structure. But in our case, we used an ADO structure, which stands for Alternative Data Dictionary. This structure you can configure here in this section, and you can see the Zilliant order flat contains those fields. Also, there are some minor variant ID dependent lines here, which is actually the advantage of taking this ADO feature here within the extraction, that you can drop certain fields which are not needed from an R3 system or vice versa. You have the data delta management, and basically filter is not switched on here. I will switch on the filter, which will only give me those rows which are dependent on this extraction model. The filter needs to be configured on the root table, and you just need to choose the date and time field that you would like to use for the data management, and the rest is done by the system. You don't have to care anymore about starting the report or the extraction at any certain times. You just run it whenever you like, and it always gives you the data, the delta that was created since the last extraction. The data manipulation add-ins can be configured dynamically. Since the filter is active here, it only shows you the ones which are used in this extraction model, but they can be configured, and whatever you need, you can set up and connect it into your mapping. So let me go into the extractor. If I enter this extraction model that we just had a look at, it will pull all the default data. We want to have a free selection based on those selection fields. We would like to have, maybe we would like to have a protocol. This creates an SLG1 protocol. And we would like to have a output to our local workstation. We would like to have a CSV format. We may also choose the JSON format if we prefer. And the output can also have dynamic components. Like in this example, I don't put a static name, but I would like to pull the name from some other parameters. If I run this extraction, it will immediately create me the output, which I can find here in my folder. And this is my CSV output based on the extraction model that we just had a look at, comma separated CSV with header line. We only have one package extracted. This is because, let me go back into the configuration. We choose a package size of 5,000 lines, and within our test system, we just have very little data. If we reduce this package size and run it again, we will get several packages output. I think this is it for a very short and top level introduction of this feature. I can go more into detail if any more questions come up. You're always welcome to contact us if any questions should still be open. Thank you for your attention.